Kia ora koutou. This video is the second one going through the basic skills checkpoint test for my level 2 stats class this year. So I'm going to try and look at two triangles in this one. I'll go a little bit faster than in the first one. This is the first question, and remember we have to find all of the angles and the sides. And then this is question 3. So looking at question 2 first, by now you should be getting confident that the first thing we have to find is whether we've got an angle and its opposite side. And in this case we do. So that means that we can use the sine rule to find side length C. So C over sine of 61 degrees is equal to 4.3 over sine of 50 degrees. That gives me 4.3 times sine of 61 degrees. And just pop that in brackets. It doesn't matter in this example if you put it in brackets, but it's just easier to always put things in brackets when you've got a fraction. Remember that that fraction line is like an invisible bracket sign. When we come to the cosine rule ones, it really can muck things up if you don't remember to put in your brackets. So let's just do it here. Okay, so that gives me an answer of 4.9095 centimetres. Now, if I'm using that in future calculations, I'm going to use it with lots of decimal places, but here I can round it to 4.9 centimetres. So if you're thinking about what I mean by that, I mean that this one is kind of like your answer, but this one here is where you're going on to use it further down. That's got us this side, so we've got 4.9 here. We still need to get this side, and we need to get angle A. Well, angle A is very easy because we've got the other two angles in the triangle. So angle A, 180 minus 61 minus 50 gives me angle A of 69 degrees. And we need that to find this side length here, which I'll call little a. So now we're good to go again with the sine rule. So little a over sine of 69 degrees is equal to 4.3 over sine of 50 degrees. We're going to multiply both sides through by this. That gives me a is equal to 4.3 times sine of 69 degrees divided by sine of 50 degrees. And I get a final answer for that side length of 5.2404 centimetres. I want you to notice that I'm always putting units everywhere, and that includes giving the degrees sign when I'm working in degrees. So what have we got now? Well, we've done the sides and we've done the angles. The last thing to do is the area of the triangle. So let's just get that done now. Let's get some space. To do the area of the triangle, we need to have an angle and then the two sides hugging it or around it. And we call this angle the included angle. So we can use any, we've got all of the sides and all of the angles here. I'm going to use what I've drawn there. So we've got 4.3 there, and this side length we've got 5.24. So the area is simply half times 4.3 times 5.24 times sine of 61 degrees, and that gives us 9.85 centimetres squared. So that's question 2 done. I'm going to squeeze question 3 into this video. Hopefully you're starting to get this pattern that we always look for the angle and the opposite pair. Here's question 3, and when we first look at it, it's kind of hard to figure out what we can do. So we don't have that pair. Here we've got B, but we haven't got that side. And here we've got this, but we haven't got this. So we can't immediately use the sine rule. Let's see if we've got an included angle. Well, we don't have that either, right? So looking here, we've got this angle, this side, but we don't know that one. So that's no good. We've got this angle, this side, but we don't have this one. So that's no good. So the only thing that we've forgotten to do is that we know the third angle, right? We do know that angle because angles in a triangle add up to 180. So we'll start with angle C is equal to 180 minus 49 degrees minus 68 degrees which is 63 degrees. So we're going to mark that on here, 63 degrees. And now we're off because we've got an angle and the opposite side. I'm going to figure out, I can do both of these. Whoops, we'll call that one little b and that one little a. So 2 lots of the sine rule, and then we'll be done. So a over sine a. Now I'm guessing some of you are going to hang up the computer or whatever you do to computers. But remember that if you're watching this, it's probably because in the checkpoint test, you couldn't do this automatically. So it's worth your time to just slow down and look at the mistake that I've just made right there. Okay, 11.2. And what am I trying to find? Oh, I need to change that a, right? This a should be 49. That's better. Okay, so that a there. A is equal to 11.2 times sine of 49 degrees divided by sine of 63 degrees. Okay, chugging it into your calculator, what do we get? We end up with 9.487 centimetres. So we're going to write that one down, but if we're rounding it, we'll use 9.5 centimetres to 1 dp. And we can do the same thing now to get side length B. So we set up a sine rule relationship, we rearrange, and we solve. We have B over sine 68 degrees is equal to 11.2 over sine 63 degrees. B is equal to 11.2 times sine of 68 degrees over sine of 63 degrees, giving us 11.655 centimetres. And then I'm going to round it to 11.7 centimetres to 1 dp. Now for the area of this one, what am I going to use? Well, I can use anything because I've got all the angles and all the sides. But I'm going to start with, I think I'll do this one because I've got that one exactly and I've just worked that one out. So the area calculation is just one line. Area is equal to half AB sine C. In other words, the angle and the 2 sides that hug it. So a half times 11.655 times, what's next? 11.655, and then what did I do now? 11.2, because we were given that in the question, times sine of 49 degrees. Notice that here I've used not just 11.7, but I've used that one that we're going to use for intermediate calculations. That gives me an answer of 49.2, and I have to give units, so it's going to be centimetres squared. And we round that at the very end. Thanks for watching. I'm too tired to do questions 4 and 5 tonight. I'll come back to them tomorrow. I can see from the views that some of you, hopefully from my class, are watching the videos and getting much better at practicing these skills.